Just calculate the omega cross V properly. You have omega here and V here. So
V is-
omega cross V.
So the thing is that V is
goes
not
to
parallel, but slightly
yeah.
into
So your omega cross V goes to the right, and minus omega cross V will be V.
omega cross V goes to the left.
So why does this formula give you a wrong result if we know that it is the other way? Are you using the correct formula, or
Yeah,
is the omega? It's, well, yeah.
No, I'm sure about that because I talked to Yasin, for example, to Professor Y, for example,
Oh, your camera.
and
Am I disturbing you with it?
No,
Don't-
of course
don't
not.
worry about it.
we are actually being recorded, by the way.
Yeah. Okay.
So that was one thing I didn't understand. Oh no, I forgot to show you everything. Wait. Yeah, so here I have an animation for you. If I find, do you want to see the animation? Because if you do, I would have to find it in the web. I've got the link here. Right. So the thing is that we are approaching the equator, and this yellow path is a straight line as viewed by aliens. And the Earth rotates from below the airplane. So from the point of view of human, the plane will be deflected to the west. And here's an example from the southern hemisphere. So it should also be deflected westwards, right? Because as we approach the equator at least. And that's what happens. So actually this path is from the point, this yellow curve is from the point of view of human, not aliens. Yeah, but they didn't do animation on what happens when we recede from equator. So we don't know. Or maybe we're going to figure it out.
I feel that it's going to be deflected to the west as well.
Yeah, that's what I think, yeah.
I mean, that's what like looking at this picture would say. However, from what I remember, it should be the other way. So I see a problem.
Okay, shall we go on to the question 7? Okay, question 7. Okay, we fly over the equator on a plane, and we can fly in one of the directions that I've shown, and we're gonna be deflected upwards. That means we're gonna be deflected away from Earth. Not by the centrifugal force, but by the Coriolis force. And it's known as effect of, and you read.
Oh, Eötvös. It's one of the principal tests of general relativity.
Oh, is it?
Yeah, it's in my notes.
What is the pendulum?
Yeah. He was a Hungarian. Yeah, Eötvös.
Right, so which way should we fly to be deflected upwards? And I'm allowing you to use this formula. I'm gonna be nice. And I'm gonna take a cookie.
Well, this formula I would say that typical is.
Yeah.
And that's the right answer. Because, okay, we still have the Earth, so this is, so this is omega. And we fly to the east. So omega cross V is into the Earth, but it's minus, so it's...
And it actually seems to make quite some sense, because like Earth is running away downwards.
From the point of view of aliens. So that's what we understand. So, but this logic would tell us that if we were flying to the west, it will be deflected downwards. But how would we explain it from the point of view of aliens?
The Earth is coming up at you. It's going away down the other side.
It's like it's coming towards us, while in this case it's
I'm not sure.
because we're not as fast as the Earth, so in this case the Earth is like rotating away from us, and in this case it's rotating into us, but it's not coming into us, is it?
Are you sure
It is
it's
coming
the
to
case?
you, I think. I think it is coming to us.
So is that what you're saying?
Well, I was wondering, can I draw it on the board?
It's a debate, you can participate, but you have a different way.
Yes, alright, I can make my way there.
I remember really
So if you look at this, yeah.
I still don't understand.
He overestimated the errors, because like, when he did it.
This is looking down. This is the north pole of the Earth. We're looking downwards, so the Earth is rotating this way. So if we take off and flying westwards, the trajectory will be like this. So we're getting further and further away, which means that we're getting higher and higher. But if we fly to the left, it's the same thing, right? We're getting higher and higher, further and further away from the Earth. So I feel that no matter which direction you are flying, you are getting further and further away from the Earth.
That's what I think.
Yeah.
But that's not the truth.
Isn't it?
But I mean,
According to story.
I have an idea, if you don't mind.
Yeah.
Basically, what's at this level down here, at this point, at the level down here, this point will end up. So it will move that way. So this point will actually move down.
Yeah,
This
it's gonna
point- this
it's
point
gonna be
is
closer to
moving
that
down.
point.
This point's moving up.
Yeah.
Sorry, can you say that again?
But basically, this point rotates to this, so when you project it to the vertical axis, it moves downwards here.
Yeah.
And this point here to the east, when it moves in that direction, so when you project it on vertical, it moves it's in that direction.
So as we
So
fly to
basically
the
here it, what's on the east moves downwards from you. And
as we fly to the left, these points recede from us and these points approach us. There we go. Okay. Makes sense. Okay, so if we fly to the north, what will happen? Probably nothing, because we are at
yeah, I
the
say
equator.
nothing, I say the whole Earth is vertical.
So if we fly to the north or to the south, this cross product is 0 because they're parallel. And also from the alien's point of view, we're not going to be deflected because the Earth rotates right to left, but not up to downward. Okay, what's next? I don't know if I should skip this time because.
But is that only at the equator? Like, because if you get slightly above the equator, then
Okay,
it's
that's all for the sign.
non-parallel to the...
Say it again, sorry.
That's only at the equator, right? Like, if you just get slightly above the equator, then you're not...
Yeah, then something would happen. Some Coriolis force and centrifugal. Okay. And when I was explaining this this cabin with tiny people in my headphones, I didn't mention that. Don't look that strange at me. There are tiny people in my headphones.
Okay, I believe you.
Did they talk to you?
So I explained that. You remember what I explained? Okay. So what I should have stressed is that the centrifugal force is actually not an effect of something moving, or not an effect of not an effect because the cabin moves or something like that, but it's because we view it from the point of view of a rotating frame. So yeah. So it's because of the way we view it, not because something moves. If I was to rotate and look at you, I would see you receding from you. So there would be centrifugal force acting on you from my point of view. And possibly Coriolis force too. Good, so I intended to tell you all that I know. So I probably should show you all the derivations I know of the Coriolis force and of the centrifugal force. So the first one I know is the one I don't trust. Is the quickest one. So we have something moving, and it's at position vector r. And we try to describe it in the polar coordinates. Okay, so we can write that r is. So if I underline it, it's a vector, right? And you're a chemist, so I have to make sure if you catch up with us. You do. I do. And this is.
I mean, basically it depends. I guess more not what subject you are doing than the country you come from. Actually.
Well, no, because I don't know if chemists do vectors.
Yes, they do.
You do
Because
sometimes.
there's nothing moving in chemistry, right? Only.
I know, that's some moving sometimes.
Okay. So this is nothing new, right? We can write the position vector as the magnitude times the unit vector in the radial direction, and then we differentiate it. Oh, and by the way, you should accept, because I don't want to explain it unless you want me to, that the derivative of the unit vector in the radial direction is
Minus beta hat.
theta dot theta hat.
Yeah. You can prove it by just writing it in spherical
Yeah.
coordinates.
Yeah. In Cartesian coordinates. And the theta hat dt is minus theta dot r hat. So it's basically, it gets rotated 90 degrees counterclockwise, this unit vector, and gets multiplied by theta dot. Okay, so if we differentiate this, or maybe you all know that and I'm just boring you.
I don't know that.
Okay. So r dot, so that's the r dt. Okay. So it's the derivative of the product, so it's r dot r hat plus r times the derivative of this, which is theta dot theta hat. So that's the velocity it's moving at. It's moving with. So this term is the radial velocity, it's just r dot, and this term is the omega r that we all know, right? Okay, and the second derivative, okay, so it's derivative of this again, r double dot, r hat,
T squared.
thank you, plus r dot theta hat, and now this term. So it's got r dot and this stuff, theta dot theta hat, r theta dot theta hat, r theta double dot theta hat, and there is r theta dot times this. So it's minus r theta dot squared r hat. And if I clean this up, so in the radial direction, I would get r double dot minus, only that, yeah, minus r theta dot squared. And in the angular direction,